Okay, so for this video, we're going to look at rational functions. We're going to be looking at the end behavior for rational functions this time. So you should have the set of notes. Be sure that you read through that. That gives you the rules. I'll go through and work the examples as well. Uh, but a rational function is basically anytime you have a polynomial divided by a polynomial. That's considered a rational function. Really, just as long as you have a variable in the denominator, that's what's going to make it a rational function. So I've got two polynomials being divided here, and my question is, what is the value of this function as x approaches positive infinity? All right, what's happening as we plug in bigger and bigger numbers for x? Okay, so if you want to, take a calculator and do something like 50 stored to x and just type this thing in, see what happens to it. That's uh, you know that's what it means for x to go to infinity. So if I do 3x squared, if I do 3x squared divided by x to the fourth minus 1, you see we're getting a very, very small number this time. It's not blowing up. It's not going to positive infinity or negative infinity. Okay? The rule for situations like this, when they are considered bottom heavy, it's bottom heavy because the degree of the bottom is higher than the degree of the top. As x goes to positive infinity, the value of the function is going to go to 0. That's going to be the answer in all situations like this. So if you ever have something like 1 over x, or 1 over x squared, anytime the degree of the top is smaller than the degree of the bottom, it's going to work out like this. All right, it's always going to go to 0. The graph, here's what the graph of one of those looks like. All right, you see here as x gets bigger and bigger, the y values are getting smaller and smaller. They're approaching 0. Okay, and that's true on the positive and the negative side. That's what's kind of nice about these rational functions is, they're, whether you go left or right, it's the same value. All right, you're still getting 0 either way you go. All right, now case 2, all right, is if the degree of the top and the degree of the bottom are the same. Okay, you see here in this one, these are both degree 3 polynomials. It doesn't matter that this one has more terms than the bottom. That doesn't matter at all. This is still considered not bottom heavy, not top heavy, but equally heavy. I guess it would be balanced is what you could call it. Okay. So we want to know what happens to the value of this function as x gets really large. So why don't you plug in some numbers for x, like say 50 or 100, and see what happens. Pause the video, try that out. Try plugging in a really big number for x, and then divide the top by the bottom. See what you get. Okay. If I look at the graph of it, it's kind of wild here. I know I'm not going to cover what all is happening in the center. That's the talk for another day. But as these x values are getting bigger and bigger, let's zoom out. Here we're at 40. Let's go over here. Maybe as x is getting bigger and bigger, we're getting closer and closer to 3 is what it looks like. Yeah. And that is our answer, in fact, in this case. And that's the same on the left-hand side as well. As you go to the left forever, as x approaches negative infinity, you're also getting closer and closer to 3. So in this case, it's 3. All right, and it's not always 3, but it is in this case. That 3, where that's coming from, is the 6 divided by 2 part. 6 divided by 2 is equal to 3. So what you do in this case, whenever the degrees are equal, is you take the leading coefficients. Again, these parts don't really matter too much. But you take these leading coefficients and you just divide those numbers. That's how you tell what the end behavior is going to look like. All right. Close my blinds. Okay. Let's see. Just need to refocus. There we go. All right. So I had a couple of examples I wanted to go ahead and look at. All right. So we'll do these two and then we'll end the video. All right, I got two rational functions, and I just want to determine the end behavior for each of these. Now, if you want to, you can just plug in a giant number for x and see what happens. I recommend you do that. It's a good way to kind of feel for these. Notice here the degree of the top. The top is a degree 1, and the bottom is a degree 2, which is going to make it bottom heavy. All right, and whenever they're bottom heavy, it always comes out to the same answer. All right. As x gets really large, the bottom is going to outrun the top part. And so what you have is a small divided by a big number. And that always kind of tends towards 0. Okay. All right. For the next one, the degree of the top is 1. The degree of the bottom is 1. So these are balanced. And what you do there is you're going to divide those leading coefficients. So I would do 4 divided by 1, because that's my leading coefficient. And that's going to tell me my end behavior. It's going to be 4. All right, that's it for the first two cases for